see that. So yeah, thank you for having me on for this seminar. Thank you for giving me a reason to put on proper clothes for the first time in maybe 9 months. Right, so yes, as Danina said, I have experience in research at the University of Exeter as a climate science communicator at the UK Met Office, and also as a science journalist at Carbon Brief. And whilst I've been in the field of climate science and climate science communication through this whole time, I've seen it from 3 very different angles, and there are a lot of interesting little observations that I've picked up along the way that I thought might be interesting to share with you all today. So what I'm going to do is I'm going to jump straight in and start with an example of how different institutes communicate the same research differently. And then I'll dial back a bit and talk about some of the more specifics. So this is 3 examples of different coverage of, let me see if I can move this bar so you don't have to look at it. Okay, so this is examples of 3 different institutes covering the 2019 Australian bushfires. So these fires were very big in the media. They also had a significant climate element to it. And so this was quite an interesting case of looking at how different institutes decided to cover this event. So I'm not going to go into a huge amount of detail here, but just as you look across these 3 examples, have a look at the different language that's being used, the different use of images, the different titles that have been chosen, and maybe start to think about who some of the audiences might be that these 3 different people are trying to communicate to. So I will tell you that these 3 bits of comms came from Exeter, the Met Office, and Carbon Brief, so the 3 organisations that I have worked with. And so very broadly, I'm going to lump these under Exeter as research. So I'm specifically looking at the scientific research that Exeter does. And so this first piece was highlighting a new bit of research that come out. Then the middle one is the Met Office, and the communication for that tends to be a little bit more towards the layperson. So it's towards government and the general public. So definitely people who have an interest in climate science, but maybe not a scientist or researcher. And then on the right-hand side, we have Carbon Brief, which is the climate journalism and analysis group that I work at the moment. And they, as you see, have gone for a media reaction piece. And so this piece was actually lots of tweets and Instagram posts, and it was very visual. And this was maybe intended at more of a lay audience. So just really quickly to run through my background, Denise already covered it pretty well, but I did my degree at the University of Exeter in natural sciences. This was a master's degree from 2015 to 2019. And that included in 2019 doing, well, 2018 to 2019, doing an 18-month research project. So the natural sciences degree is quite broad. You start by doing a range of subjects: biology, chemistry, maths, physics, anything you want, and then you specialize down. So I only really started to specialize down into climate science around 2018. Then from 2018 to 2020, I was working at the UK Met Office as a climate science communicator. So this started with an internship in the summer of 2018, and I was then very fortunate that I was offered the chance to stay there and work part-time throughout my master's year and then get a full-time job afterwards. And then very recently, just a few months ago, I started working at Carbon Brief as a science journalist. But I did also do an internship with them, a 2-week internship in the summer of 2019, where I looked at a whole range of different sides of the company. I was able to work with pretty much everybody in the company over those 2 weeks. And so when I came into the job as a science journalist, I already had quite a good idea about who Carbon Brief was communicating to, how they were trying to communicate. And I think that's helped me sort of jump straight into the job a bit quicker than I might otherwise have done. So I'm just going to really quickly run through those 3 institutions I've worked at and talk about who I was trying to communicate to when I worked there, what kind of science I was trying to communicate, and how I went about doing it. So as you saw in that first example I showed, you can take the same piece of information and communicate it in very different ways. And so different institutes have, well, different norms, different ways that they like to do things, but also different ways that they have to do things based on who they're communicating to. So as I said, I started off at Exeter University. And when I was there, it was a very scientific degree, very technical, mathematical. In my fourth year, I did a lot of fluid dynamics, so that kind of module. So there wasn't really much scope for writing within the course. And my assessments were mainly presentations and posters, and they were aimed at other scientists. So definitely not a lay audience, definitely an audience who very much knows a lot of the science that I would be talking about already, that I can really get very technical and in depth with. And I didn't need to worry about getting a hook or drawing them in, because I knew they were already interested. So that kind of assessment I could just dive straight into. Dive straight into the science. But whilst I was there, I did still want to write. I really have always enjoyed writing. And it was quite sad to me when I picked a degree that I thought was going to cut out all the writing from my life. And so I actually wrote for and edited for Expose and the undergraduate STEM journal. So Expose is the student newspaper, and the science, so I was the science editor for that, one of the science editors, and I would classify the communication in Expose as pop science. So it definitely had to have a hook, it had to draw people in, the details of the research were quite limited. Whereas the undergraduate STEM journal was more condensed versions of research papers. It was students writing in with articles that they wanted to submit, and then we would go through the process of making sure the science was rigorous. And so that gave me a good range of sort of science publishing knowledge throughout my university time. The other thing that I did was attend a lot of conferences. So the image on the bottom, I'm sure some of you watching are in this image that's at the bottom, was the James Lovelock Conference. It took place at Exeter University, and it was celebrating the life of James Lovelock, who was turning 100 at the event. It was celebrating all the work that he did implementing his theory called Gaia theory. And I am here in the middle. Oops. And I'm sure a lot of you can find yourselves in that picture. But during this time, I made really detailed notes during this conference. It was a 3-day conference, and I made notes on every single talk that was given. And at the end, I had this massive stack of notes. And I thought, okay, I know this conference is going to be one that I want to remember. I need to do something with these notes. And so I decided to write a piece. I wrote, I think it was a 12,000 word piece. I put it on my blog. And that was when I realized, I actually really enjoy writing up science, writing up scientific research for this kind of audience. I was kind of aiming at a slightly educated, but mainly lay audience. And I thought, this is what I want to do. I really enjoy writing. So in the summer of 2018, I went to the UK Met Office. I did a 3-month internship that I felt very fortunate to get. So that image on the bottom left is me and the other interns from that year. And we did 3 months. We were all working in different departments. And I was working with a group called the Knowledge Integration Team. So the Knowledge Integration Team basically is the bridge between the scientists at the Met Office Hadley Centre who are doing research and the people who need to get that information. So the government, the general public, anyone else who wants to know. So as any of you who've read a scientific paper probably know, they can be quite dense. It can be quite difficult to extract information from them. And government ministers do not have the time for that. So it was our job to talk to the scientists, to read the papers, to extract that information for them, and then to feed that on and to present it to them in the best way possible. So what did that involve? Well, for the government, that involved a lot of briefings and paper summaries. So a briefing was maybe a single-page document that would summarize a paper. And when I say single page, really in terms of text, it was like a third of a page, because this single-page document included a lot of headings and little boxes that took up space. So in terms of text, it was a few hundred words summarizing the paper. And then if the paper was relevant, then we would maybe put a bit more time and effort into it and produce a briefing that could be a couple of pages. I also did a lot of podcasts and interviews and presentations. So in the last year that I was at the Met Office, I underwent a media training morning. It was very intense. I got asked some very difficult questions, but it taught me how to answer questions well and how to present effectively. And it basically meant that I could then become a spokesperson for the Met Office. And so I had a really good time. I presented a podcast called the Mostly Weather Podcast with Doug McNeil. We did a couple of interviews, and I presented a lot, both internally and externally. And again, I realized that I really enjoy it. I really enjoyed communicating information to people, not just through writing, but verbally as well. So in terms of the general public, as well as these podcasts and interviews, the team I was working in, also produced a lot of infographics. So an infographic, as the name kind of suggests, is information represented in a graphical form. So bottom right is one example of an infographic that the Met Office produced. And I'm actually not going to go into too much detail on that now, because I'm going to come to that later. The other thing that I did a lot of, or one of the other main things that I did a lot of, was producing content for the Met Office website. So specifically the climate science pages of the Met Office website. So the website was first designed many years ago, and it needs constant updates. Any website needs constant updates. And the climate science pages had not been updated for a while. And so it was my job to go in and both redo the entire structure of the website and to write a lot of new content. And to do that, we really had to go right back to basics and decide who was this content for. We decided that the content was to be for the general public. We decided that the government had their own briefings and summaries. They wouldn't need the web content. And so we decided that we needed to make this content suitable for the layperson who knows nothing about climate change. And at the time, it really did not serve that purpose. And so that was one of the main things that I was working on over the past year. Now, again, I'm not going to go into too much detail on that, because I will come back to that later. And then finally, we get to now, which is my job at Carbon Brief. So Carbon Brief is a climate science, a climate journalism and analysis group, which focuses on science and policy. And so, as I mentioned, I did a 2-week internship in 2019. Then, whilst I was working at the Met Office, I did a fair few guest posts working with the scientists at the Met Office, and then became a science journalist officially from the middle of November 2020. So I'm still very new into this role, I should say. So I have a few main jobs as a science journalist. It is a very varied role, and because the team is so small, there's only about 9 or 10 of us, it really is sometimes a case of everybody pitching in and doing whatever needs doing. But I do have some defined roles. So one of them is that once a week, I write what we call the daily briefing email. Now, this email is a summary of everything that's happened in climate science and policy over the past 24 hours, or over the past 72 hours on a Monday. The email only comes out Monday through Friday. And you can see a snippet of the email on the bottom left. So what that involves is basically getting up really painfully early in the morning, going through all of the news, main media outlets, and pulling out important science and policy information to do with climate that we think people would want to know. So if you don't get this email, I do recommend it. Obviously I do, but it is a very useful summary. And at the Met Office, I did used to read it every day, and it really set me up well for knowing what was happening in climate for that day. So another main job that I have is writing up science papers. So when a paper is published, a scientific paper, there is usually a period of embargo where the paper is available to journalists and media outlets, but it has not yet been published. And so when I get an email saying that a paper is under embargo, I can often get a hold of that paper ahead of it being published, and I can write a piece on it coinciding to come out with the time of publication. So for example, there is a paper coming out in Nature this afternoon at 4 p.m. that I have written a piece for, and it's now done, it's finished, it's waiting in WordPress, and it will be published at 4 o'clock when the paper goes live. And what that means is that when this paper comes out, if people see it and think it's interesting, they may not want to read the whole thing, or they may not know enough about the topic to be able to access the whole thing. This piece is about 1,500 words, maybe 2,000, and it should just be a good summary of everything that's in that paper at a decent level of depth for someone who's interested, but without too much of the technical jargon. As well as doing these write-ups of science papers, I also write features sometimes, or I will write features sometimes, which are a bit longer, which pull out a lot of information about a topic. And then the other thing I do is assist the policy team in some of their work as well. So once a piece has been published, there is a lot of promotion that needs to go into it. You can't just expect people to find your piece if you don't publicize it. So there's a lot of work on graphics and social media that goes on in the team. So as I mentioned, the team is quite small. There's only maybe 8 or 9 of us. And of those people, 2 are specifically dedicated to graphics and multimedia, and 1 is specifically dedicated to social media and WordPress. And that ratio really surprised me when I first joined. I thought that was very heavy on the graphics and social media side, given that there are only 4 or 5 of us actually writing content. But actually, it really makes sense, and there is so much for this team to do. And so I try to assist, we all try to assist wherever possible. So the middle graphic is a tweet that I put out summarizing some of the key points of a recently published article. And I wrote this as a Twitter thread. So for those of you who don't know, a Twitter thread is just a series of tweets that all follow on one after the other, and you can read them almost like a little story. And so I do try to produce a Twitter thread now for every article that I write up. Then on the right-hand side, there is an Instagram card. So these cards are made specifically for Instagram because Instagram is very visual. They're not used anywhere else. And these cards generally use quotes from the lead author or from a commenting scientist. And the purpose of these is to draw people in. It's not giving you a huge level of depth about what happens in the study, but it's just designed to pique people's interest, maybe make them want to find out more. Right, so I'm going to run through now some of the different methods that I've seen for people communicating climate science in different sectors, some of the things that have jumped out to me, and obviously happy to answer any questions about this at the end. But because I've now been talking for maybe 15 minutes, and I'm sure you're all getting sick of my voice, I'm setting a little task. So what we have on the left here is the Flesch readability score. And what this is it's just an assessment of how easy or difficult a piece of text is to read. So every piece of text can get a ranking between 0 to 100, where 0 means it's very difficult to understand, and 100 means it's very easy to understand. Now, there is an equation that can be used to calculate these numbers, but I'm not going to give it to you yet, because what I'm hoping is that everybody could have a go at just typing in the chat what they think the numbers would be for these 3 bits of text that I've written out here. So if you want to have a go at just trying to type out a number, just pop it in the chat, what difficulty you think these 3 pieces of text are, whilst I just have a quick drink. All right. Okay, we've got some things coming through in the chat. A lot of people thinking 1 is somewhere around maybe 30. We've got as high as 90 for the last one. We've got as low as 5, I think someone says, for the first one. So, okay, I think everyone's generally got the idea that the first one is definitely the most complex, so the lowest score, so that's good. That means I've explained that well. All right, I'm going to give it 10 more seconds and then I will give you the answer. And for those of you who are feeling very keen and want to check that I've done this correctly, I'll give you the equation as well. Right, so this is the score. So, you know, if you got within 5 or 10 of the correct answers, give yourself a pat on the back. I think a lot of you have. And then this is the equation. I don't know quite where this equation comes from, but that's what the equation is. And so the way that I checked this was using Grammarly, which is a tool online. I'm sure you can do this using other tools as well. But this is what the scores are. So you can see, as you all guessed, the top one is the most difficult. And the way that we're calculating this is we're just looking at the number of words per sentence and the number of syllables per word. Basically, we're saying that the longer things are, the more difficult they are. And obviously that description lacks a lot of nuance. There are many things that can make a piece of text easy or difficult to access, but this is just a good baseline, a really basic starting point. So I've just put here on the side where I think you might find pieces of text like this. The top one, I think, is maybe something you would find in an academic paper. The middle one is maybe a website for the general public, maybe the public who are already interested or engaged. And I will tell you, actually, the middle one is text that I wrote for the Met Office website to replace text that was more like example number 1 that was really complex. And then the last one I'm calling for the unengaged public. And what I mean by that is for the general public who don't have a pre-existing interest in the topic of climate change and who aren't going to spend time and effort wading through complex text. And so you really need to make it easy for them. If I just go back very quickly to the previous slide, because I just want to show you. Okay, so text in the final example sounds quite easy. When I say it to myself or imagine saying it to someone else, it sounds very condescending and easy to me. And I just want to make the point that it's got a score of 76, which is considered in this table easy to read, but it's still considered more advanced than conversational English for consumers. So the average person would still find this hard. And this is something I try to bear in mind whenever I'm thinking about what level I need to communicate at. So I expect many people on the call have been quite lucky in that we've been around academics and people with quite complex levels of vocabulary for a lot of our lives. But we have to remember that that's not the case for everybody. And I think that's a really important point that I just want to emphasize. Right. So the bullet points I put on the left, I'm judging, as I said, the first example to be like an academic paper. And so just a few characterizing factors of those. They have a lot of jargon, so technical language. So for example, anthropogenic, pre-industrial, quite complex words. But you can be very accurate and you can communicate very complex concepts using those words. But maybe you can't communicate as easily in the other examples. But the main issue in my head with this is that this level of language can be such a gatekeeper to anyone who's interested in science but doesn't have the background. By gatekeeper, I mean that if you are engaged in science, if you're interested and you want to know more, you might be really put off by this text and it might prevent you from going any further. And we don't want to be discouraging people. So whilst this level of text is fine for an academic paper, it would not be good on a website. Then on the left bottom, I've put social media. So the bottom bit of text, I'm judging as something that maybe could go on social media. So it has short sentences, short words. I've made an effort to minimize jargon. If I was going to put this on social media, I might add a couple of emojis as well. But you will probably all see it is less accurate. It does lack the nuance of the first example. So in the first example, where I specifically talk about the pre-industrial period, in the third example, I just say almost 200 years, which is much less precise, but it is much more accessible. So when you're pitching your writing and speaking, you need to decide what level on this sliding scale between accessibility and complexity you want to hit. Right, so the next thing that I have noticed is, for me, I think the most striking thing between the 3 organizations that I worked with is the narrative, so the order that information is presented. So a lot of you are probably familiar with how to write an academic paper. I know that I spent most of my formal education learning how to write in this style. And the way that I was always taught to write one, maybe you will have slightly different ideas, but the way I was always taught was you do an abstract first, which is 1 to 2 sentences from each subsequent section. Then your introduction, which is the justification for why you're doing this research and any background information that's needed to interpret the results. Then is the method. So what did you do? Technical details, models, data sets, etc. The idea being that anyone reading this paper should be able to reproduce it, more or less. And then at the bottom, findings and discussion. So this is basically the reason for publishing the paper. This is what's new, what's exciting. This is where most of your figures will go. This is where any implications for the future or for the reader will be made more apparent. And there really isn't much of a limit on the length of these documents. I mean, I've seen papers that are hundreds of pages long once you add in all the extended figures and stuff. So that's what I always grew up learning about. And so when I went to the Met Office, we used to often, as I mentioned, summarize papers for scientists, papers from scientists for the government. And we would do this by just writing single page documents. And so we used to follow this format. We do an abstract, then the introduction, then the method, and then the results. Just because that order kind of made sense to us. Sort of, why do we do something? How do we do it? And what do we find? It seemed to work. But we soon got feedback from the government officials who were reading these cover sheets, that they were too complex, that they were not doing their job and communicating information effectively. And so we actually moved to a slightly different system. So we started with the summary, and our assumption was that the summary was all that our government official was going to read. We tried to pack everything into that summary that they could want, because we were assuming that they wouldn't even get past it. And so this was mainly actually basic science and the results. So there always has to be some level of basic science that you need in order to understand a piece of work. And so we had to put that in. But as soon as we'd done that really basic explanation, we went straight to the results and told them why this research was important. Then under the summary, assuming they made it that far, then we had the key headlines and we had recommendations to the reader of what they needed to do. So for any climate change paper, it was usually, please push mitigation and adaptation actions, reduce emissions, prepare yourselves for climate change, but a bit more specific usually, but that's where that went. Then there was more specific media and policy advice. So we would advise on how high profile the paper was, how much media attention it was going to get. And if it's a low profile paper, chances are they wouldn't have read this far anyway. But that, and then the relevance to the minister, so why you should care. And then at the very bottom, in case they were interested, background, science, methodology, but we kind of assumed that no one ever got that far in these cover sheets, to be honest. And so that was, in my head, that almost flipped the order upside down from what I'd been taught, which was very jarring for me. And then I went, oh, come on, next slide. Then I went to Carbon Brief, and the order got even more, well, messed up in my head. The order changed even more. So for a Carbon Brief piece, it's roughly 1,500 words. And so you can assume that the reader has some kind of interest in the piece. Otherwise, they're going to click on a much shorter summary than something this long. But here, the most important thing is the title. So when you're picking a title, you want something that captures the interest of the audience, something that is engaging, but also it needs to not misrepresent the science in terms of highlighting one finding more than another, for example. And so after a title, then you have a sort of top line paragraph, which just includes your very main findings. And the other thing that I forgot to put here is that you have to pick an image to go at the top, a hero image, we call it, which is the image that goes in the banner up at the top and that people see with the title. And again, you have to make sure that image is appropriate for the piece. And so one example, I have a piece coming out in an hour and a half, goodness, that's about, I can't tell you too much about what it's about. It's about bodies of water. And that can be quite pretty. And so I was looking for images of these really gorgeous bodies of water that I thought would be engaging and draw people in because they would look nice. And then the editor sort of came and said to me, Ayesha, I mean, these pictures are gorgeous, but isn't the finding of this study negative? Isn't this finding bad impacts on ecosystems and people and stuff? Like, should these pictures really look so glamorous? I think is the word he used. And I sort of thought, okay, see your point. And so now we found some slightly less glamorous images. But it's striking the balance. The image couldn't look completely disgusting or no one would have ever clicked on the article, but still it shouldn't be seeming to make the research too glamorous. And that was a balance we had to strike. So then we get to the summary of the rest of the article, basically. So this is the bulk of the piece. You break it down into subheadings, try to omit technical details, but we do in Carbon Brief pieces provide links to things like data sets and explanations on models, explanations on things like RCP scenarios, for example, so that if people want to learn more, they definitely still can, but it's not included in the bulk of the text. And then one of the really important things, one of the things that I have found so difficult, and I'm still trying to get my head around, is the importance of front loading your information and your figures. So what that means is pushing everything important as high up to the top as you can, because you're assuming that your reader is not going to make it all the way down to the bottom of the piece. The majority of readers don't make it all the way down to the bottom of pieces. And so you have to assume that anything important you want your reader to know is only going to be seen if it's high up top. And that, again, really kind of flips the order of your piece. It puts your results and your analysis at the top, and it puts all the a lot of the scientific details down at the bottom, which is quite jarring. And then we have the unengaged general public. And so for this, I'm using the example of a Twitter thread. As I mentioned, a Twitter thread, a series of tweets that sort of tell a story. And as I said, I write one of these for every piece that I publish. Now, these can take a while to write. So for example, I haven't written one yet for my piece coming out at 4 o'clock. I think it's going to be hard pressed for me to write it in the hour between 3 and 4 o'clock after this talk, because it's much harder, I find, to write simple text than it is to write complex text. So your first tweet needs to be a really engaging summary tweet, just a sentence or so. Again, use your emojis, include your main findings. And then in subsequent tweets, you mainly include the results. You don't really talk about the methodology very much. And it's good if you can break things up with bullet points and emojis, include images and GIFs to get more engagement. It's good if each tweet can be its own point, if possible, so that each tweet can be retweeted and referenced to individually without the rest of the Twitter thread being needed. But again, I'll talk a little bit more about this in a minute. But this art of writing a good Twitter thread is something that I've found very difficult. I'm still not there with, but it's definitely important for people who maybe still are interested in the research, but either don't have the time or the scientific background to understand it. And I think for me personally, this might be one of the most important stages of communication, because it's drawing in people who aren't already engaged in the scientific community. And so for me, this unengaged general public stage is the one that I want to put the most emphasis on. So as well as this, as well as your narrative and everything else I've talked about, your language, you can also use images. So Carbon Brief is really good at producing good summary images. Now, both of these images are taken from pieces that were upwards of 10,000 words. I want to say upwards of 15,000 words. Actually, they were basically like 5 normal pieces all tacked onto each other. And so that can be really, really long and daunting. And so what Carbon Brief does is it uses links at the top of the article that can take you down, drop links they're called, that can take you down to specific points in the article. But also it produces these really interesting summary figures. So the one on the left was from a policy piece about the use of hydrogen. And so it's just got some very basic text, and it's got the top left, you can see the little tagline, how low carbon hydrogen could be made, moved and used. And then on the right hand side, we've got a science one, and this was from a tipping points piece done by Rob McSweeney. So the hydrogen piece was by Josh Kabatis, I should say. So this tipping points piece on the right has, as you can see, a map, and it divides up the 9 tipping points that we used into 3 categories. And that just allows you to divide them up in your head a bit more, I feel. And so this is something that I refer back to a lot when I'm trying to remember what the key tipping points are. I think it's really useful. And so I hope that I'm going to use more images like this when I start doing big pieces, hopefully in the future. Another thing that you can use is charts, so plots and graphs and maps, that kind of thing. So on the left, we have an example of how Carbon Brief communicated the State of the Climate 2020 report. So this is a report produced by the World Meteorological Organization every year. It's about, I mean, this year it was about 38 pages long, I think. And so Carbon Brief condensed it down using mainly figures. So images like this one on the left. And when you actually go and look at the Carbon Brief site and look at the original figure, you'll see that it's made using a thing called high charts, which makes it interactive. You can look at individual data points and interrogate the data a bit yourself. And that I think is really useful because it allows the reader to interrogate the data as much or as little as they want. You can just take it at face value like this, or you can really go in and start comparing things. But yeah, for this State of the Climate piece written by Zeke, he basically told us a story through these figures. So he used the figures to guide his text. And then when he produced the Twitter thread on it, I should say Zeke is fantastic at Twitter threads. If you want to learn how to write them, look at his. When he then went to produce the Twitter thread on it, he again told us a story through images. So his first tweet is this one at the top. And you can see he's just used arrows to show the very key results. And then for every subsequent tweet, every single one, he bases it around some kind of image, or maybe around another article. Yeah, and so this one was about ocean heat content, this image. And so this was a massive long Twitter thread that he did, but it got fantastic engagement. And you can see that because he made this tweet usable on its own, it didn't have to link to the other tweets in the thread. You will hopefully understand it without the other tweets in the thread. It got a lot of engagement just as its own tweet. So you can see 7 retweets down there, a couple of comments. And so that's good. That's kind of what we want. We want to be able to share individual tweets without the context of the rest of the article. But a lot of people are not so good with graphs. A lot of people are not very good with numbers. And so the Met Office, when it's communicating its State of the Climate report, it uses infographics. So as I mentioned, an infographic is a graphical representation of information, data. And so you can see here we've got the 2018 and the 2019 State of the Climate infographics that the Met Office Knowledge Integration team produced. And you can see it's limited text, it's mainly images, it's bright colors designed to draw the reader in, and it's breaking, each one, although they're doing it in different ways, is breaking the information down into little discrete chunks, into little bubbles on the left-hand side, into little sections of the magnifying glass on the right-hand side. And that's good. It allows readers to easily break the information down in their head and only access 1 or 2 of the bubbles if they want to, for example. The other thing here is that you can very clearly see that they are Met Office infographics. Even if you don't have the banner at the top, you can tell from the style of the graphics that it's Met Office branded. And so I actually produced an infographic when I first joined the Met Office about the impact of climate change that I thought was really cool. I was really proud of it. But now I look back at it and I think it is a good infographic, but it's definitely not within the Met Office style. You can tell at that time that I was new to the Met Office and I didn't understand much about the style of how the Met Office does its infographics. So you can also use graphics that are not static, so GIFs and videos. And so again, this is something that Carbon Brief does really well. So on the left, we have a little GIF that was made for Instagram that shows the United Nations Environment Programme GAP report, the UNEP report. And it received really good engagement on Instagram because it's very engaging. It's very, well, colourful for starters, but also the message is quite clear, I feel. And it really draws the viewer in and it lets them get the key points of this report without having to read the whole thing. This sort of static that it's on right now is kind of the main points of the report. And then on the right, I'll play it again. There's an interactive data viz that the fantastic design team produced for a piece that I wrote before Christmas, it was, about gender inequality and how it could change under different SSP scenarios. So the SSP scenarios are just stories of socioeconomic developments that the planet could go through. So if I just play it again, orange indicates high levels of quality and purple is high levels of inequality. And so you can really go into as much depth as you want with interrogating this data. And I think, again, it's quite engaging, draws people in, and stats show that these kind of maps and graphics really are good for user engagement. Right, so I'm almost out of time, just a couple more slides. Now, oh, right, that's it. I have to stop the video before I can go to the next slide. That's why. Right. Now, I would be remiss if I did this talk without mentioning the climate stripes. I know, as I said, I'm running out of time, but I just want to talk about these quickly. So if you haven't seen these stripes, I don't know how you've managed to avoid them for this long, but here they are. So this is the climate stripes from Ed Hawkins from the University of Reading. I've put his website link down at the bottom. And this is just a fantastic piece of data visualization. So for those of you who I haven't explained the stripes to, hopefully you can guess, if I tell you they're to do with climate change, hopefully you can kind of make an educated guess about what they might be showing. But each stripe is the average global temperature for 1 year, and left to right it goes, I think 1850, but don't quote me on that, up until the present day. And the color indicates the temperature. So blue is colder and red is hotter. And so what this does fantastically is it communicates a very simple message that temperature is increasing without the need for numbers or words. So it's international, it can be used in any country because there's no words. You don't need to understand numbers to read it, and it plays on our very integral sense of color, that red means danger. It can also be any shape or size, so it's been used on cars and ties and mugs. I've seen it on all kinds of things. It can be personalized to your location, so to your region, if you get the data. And it's very easy to update. Just every year, you just stick another stripe on the end, and that's very quick. You don't need to go and redesign the whole thing every year that new data comes out. And so this is often touted as like the pinnacle of visual climate communication, and I think I agree. And so I would be remiss if I didn't just mention this quickly. So just before the end, I just want to talk about a few of my key takeaways from working in these 3 different organizations. So as I said, I have worked now in academia, government, and media, all doing the same kind of communications, but all communicating the same kind of information, I should say. The thing that strikes me most, if I had to put my finger on one thing, is that the pace of these 3 institutes is just so different. So when you're a researcher, you have years, if you want, to put out a paper. You're really expected to put in a lot of time and energy, and if you spend 6 months going down a rabbit hole and find nothing at the end of it, that's still considered time well spent. Whereas then when you move up to government communications, your timescales get a little bit shorter, so I would have a few months per project maybe, and it's still not rapid fire, but you definitely can't spend time researching something just for the interest of it. It's still goal driven. And then journalism at Carbon Brief, the pace is just something else. Everything goes so quickly. So often I will write a piece, one of my 1,500 word pieces. I'll get the paper on an afternoon and have maybe 48 hours to write the piece and get the quotes and get the data viz sorted. And I should say that Carbon Brief isn't even a very rapid paced example of media. It's, 1,500 word articles can't be rushed. Whereas if you go somewhere like, The Independent, so the girl who used to have this role that I'm now working in, she's now at The Independent, Daisy Dunn, she's their climate correspondent. And she now puts out a much more rapid turnaround of articles than she ever did at Carbon Brief. And they're all shorter, but she has less time to do them. And the expectation of what you can produce in a given amount of time changes so much between these organizations as well. And that's the main thing that's really stood out to me. Just a couple of other things to mention. If I leave you with one message about communicating climate science, it's about the importance of front loading. So front loading, as I said, is the pushing important information up to the top of your piece thing. Unless you're writing in a journal and it requires you to have a certain format, I would always recommend pushing important things to the front. So most websites see a bounce rate of between 26 and 70%. Now that means that your bounce rate is just the percentage of people who go onto your website and then leave again immediately. So often up to 70% of your viewers enter the website and then just leave immediately again. And so you can have to assume that whatever they see on that snapshot of the screen when they click into it is all that they're going to take away from it. And so it's really important that if you have information that you want them to know, that you put it as high up as possible. I think that's a really, really key point. And then even once they start scrolling through the article, you can measure, it's called measuring the scroll depth, and it's usually measured in percentages, so 25, 50, and 75, and 100% scroll depth. Again, scroll depth tails off as you start to go through an article. So even the people who do have interest and start to read, they might stop by half the way through the article. So it really is important to give a kind of hierarchy to the importance of your information. And then just a final point on social media. I have only really been using Twitter properly for about a year, maybe 6 months, really intensively. And I can say that it is really useful, and that it can be useful for anyone, for any type of academic researcher, any layperson. It doesn't really matter who you want to communicate the information to. There's a huge audience out there on Twitter, and there are a huge number of different types of social media. And I think that it can always be useful to invest in, because you can either look for gaining new followers, new audiences, or you can look to inform your existing audience. But I think that it's important that as scientists, we communicate our research. I think that if you produce a research paper and then don't make any effort to try to communicate it to a lay audience, you've missed out on the vast majority of the population. And so I think that is really, really important. So I'm going to leave it there, and thank you all for listening, and happy to answer any questions that anyone has.
Wonderful, thank you so much, Ayesha. Yeah, that was fascinating. I'm sure there was something in there that everyone in the seminar has can learn from. And yeah, I'd never come across the climate, was it called the climate stripes before? I'm feeling a bit sheepish, but I know what my my new curtains are going to look like. Right, should we go into the Q&A? Please, yeah, raise your hand if you have a question, and I will come to you. Looks like we have one from Neil Mackay. Please go for it.
Mackay.
Oh
yeah, that was a really nice talk. Thanks for that. I just wanted to ask how much, I know obviously you have very short timescales, so I'm guessing the answer is not very much, but how much interaction do you have with the scientist who wrote, or the scientists who wrote the paper, if you're doing a piece on a scientific article?
So at the Met Office, it was really fortunate. I had a really immediate access to the scientists. So the Hadley Centre is this fantastic sort of hub of climate scientists that I basically sat in the middle of. And so with them, my job was basically just to pester people all day, every day, just walk up to their desk and ask them to tell me things. And they were always really nice, and they did so. Obviously, at Carbon Brief, I can't do that. So what we tend to do is email the lead author as soon as we get the paper, and ask them for quotes and comments, ask them to elaborate on any points that they want to, that they don't think have been covered sufficiently in the paper, and then we'll include some quotes from them in the final article. At Carbon Brief, we also do have some contributing authors. So, for example, Peter Stott from the Met Office, he's an expert on attribution. So attribution of extreme weather events, determining how much they were due to climate change. And he is really good at providing data for us every year to update our interactive attribution map. And so we work quite closely with him. I think one of the things that Carbon Brief is good at is that we actually do have quite close ties with the scientist, whereas maybe a lot of other media organizations don't. But yeah, so not as much as I did at the Met Office, but definitely still something.
Thanks. Right, I think Tim, I think you were next to have a hand up.
Thanks, Ayesha. That was really valuable. So my perception is I find it a lot easier to get a lot of coverage for the bad news story, in my case on climate tipping points, than I do to get coverage on the good news story of here are some positive social tipping points to avoid the bad climate tipping points. Although thanks to you or to Carbon Brief, who did cover that last week. I don't know, I was curious if that tallies with your feeling. And for me, I find it kind of frustrating because I think we know what the problem is, but we desperately need to come together on the solution. So I don't know. I think Carbon Brief is obviously working on both fronts, but any thoughts you have on that are welcome, and how we can push the positive messages, I suppose.
Yeah, so I absolutely agree. That definitely ties in with my experiences. So I've only published a few articles so far, but I would consider 2 of them to have been bad news stories and 1 of them to have been a good news story. The good news story was the one that I was the most excited about, and it just really flopped on social. Well, it didn't flop, but it didn't do as well as this really bad news story on social media. I think often people are still drawn to the look how bad this problem is thing rather than this is what we can do to fix it. And honestly, I'm not sure what the solution to this is at the moment, except to keep pushing the good news stories and to really use everything that we've all learned about communications to try and get those stories out there and to all be aware of this problem. But yeah, I mean, I completely agree. And I've seen that with your tipping points work as well, that really is an issue.
Really interesting. Thank you. Right, Matthew, I think you were next.
Hi, Ayesha. It was a really good talk. Thanks. I was thinking a lot of the papers that come out are quite sort of niche and only quite relevant to scientists. And so when you, well, a lot of them are. And so when you mentioned that at the Met Office, you do briefings for the government, what kind of papers were you covering for the government? And like, what were they actually interested in?
It's a really good question. So we would tend to do a cover sheet for the vast majority of pieces that got published, provided that, as you said, they had some kind of government interest. And I think maybe it was, pulling numbers off the top of my head now, probably about half of them ended up getting a briefing note. We ended up considering being applicable to government. And mainly that was if they could do something about it. It's a bit pointless and depressing to give people news that they can't do anything about. So unless it was something that was really big and high profile, we tended to not bother sharing it too much with the government unless there was actually an action that could be taken. So I guess there were two categories. There was the really big important news that even if you can't do anything about, you need to know. So that the Australian bushfires had a climate link. They were done, they'd already happened by the time we told government that, but it was really important that they knew it so that they could appreciate the significance of the role that climate change played. But for other things, it was a lot of, for example, work that was done in helping other countries with their mitigation and adaptation strategies that the government could actually play a role in, that we tended to communicate with them. Yeah.
Great.
Thanks. That was really helpful.
Right, Paris, I think you were next.
Yeah, hi Ayesha, that was really, really good and really informative. My question was, given your experience in sort of climate science reporting, how do you think you communicate uncertainty in climate science? Because how scientists put it out and how the general public sort of takes it in are two very different topics and two very different sort of ways that happens. So how do you think you have done it in your experience, and how do you think it should happen?
That's a brilliant point. So yeah, in scientific language, saying uncertainty obviously means we had 10 models, this is what the variation was between them. But if you say that to a general public member, uncertainty means we don't know. And so that can be a really tricky bridge to cross. So I remember seeing a talk about a year ago that I thought was fantastic, and it put across 5 main points for communicating uncertainty. So I might forget them before I get to 5, but you start with the things that you definitely know. So you don't start with the temperature uncertainty was between this and this. You start with, we know that temperatures have increased by blah amount. And you don't use the word uncertainty, you use words like range. You try to represent things graphically, because if you can see the uncertainty compared to the known value, then that really puts it in context, and that can show the uncertainty was only, I don't know, 10% of the actual absolute value. So we can be this sure. I've forgotten the last 2. I might have rolled them into those first 3 points. But yeah, I think avoiding the use of the word uncertainty and showing it in other ways is probably the most important.
Really good, good tips. Thank you. Right, Stuart, I believe you had a question.
I did. Hello. It was yeah. Thank you, Ayesha. So the emails are really useful as well. But I think probably communicating outside academia is something that we maybe all are guilty of thinking we're better at than we actually are. And I think I've learned a lot today. But I had to ask you about emojis. Do we really have to use emojis when we're communicating on Twitter? And if so, I realize it's not an easy question, but which ones should we be using? What sort of level of emojis are acceptable, and what sort does start to perhaps devalue what we're trying to say? Can you give us any thoughts on that?
Yeah, absolutely. So as I mentioned, I'm still very new to the Twitter game. And so, as I said, if you want to look at people who really do tweets well, Zeke and Leo are very good at their Twitter threads. But I do find, based on the few that I've done, that the ones with emojis do get more engagement. I try to just use them sparingly. So I do see some people who absolutely pepper the text with emojis. I try to not do that. I try to not use emojis in place of text. I try to use them to supplement. So I tend to use a lot of the little increasing graph and the little decreasing graph, so that if people just see the word sea ice and the decreasing graph and don't read the rest of my sentence there, they'll get the gist, but they can still read the whole sentence and it will make sense without the emoji. The one place where I'll say this sometimes isn't true is when there are bullet points and I use the up and down arrows instead of saying the words up and down. part of that is just to help with my character count. I don't think you have to use them, absolutely not. And it depends what tone you're going for. So if you're going for a really informative and technical tone, then maybe emojis might undercut the message. But if you think that you're going for any kind of non-academic audience and you can get them in there in a way that doesn't undercut the message, I would recommend it.
Great, thank you.
Thank you. Timothy, the final question.
Thanks, Ayesha. That was a great talk. I'm a bit puzzled at speed of communication. I mean, there seems to be an increased drive to getting it out there quickly, tweeting it. Is speed actually the most effective way to communicate things about climate change, or do we respond longer, better by taking a longer view, the long learners? I'm just wondering how you measure. It's not just the people you reach, it's actually the behavior change and the message we're getting across to society in general. And that if something's very quick, it's here today, gone tomorrow, and then it's over and on something else. It's the things that actually you remember and actually take months to actually process in your head. And I wonder how you get the balance. And have you got any examples from government where you've been successful in changing or having a policy altered, and things which are sort of ignored? I don't know.
Yeah, that's a really interesting point. So actually, back when I was working at the Met Office, we often worked with external groups, and one of the ones that I did was I worked with Copernicus, and we were working on a prototype attribution service. So what this means is whenever an extreme weather event happens, say a flood, it's often partly due to climate change, but we can never just say this flood was due to climate change, because that's never entirely the case. It was always that the flood was made a bit more intense or a bit more long lasting or whatever. And so an attribution study basically pulls out those numbers. It says this flood was made X times more likely and Y times more long lasting. But one of the issues with attribution study is that they can take a while. And for the general public and for the government, it's difficult to present a study and say, oh, hey, do you remember that thing that happened 2 years ago? Yeah, here are the numbers on it now. Because kind of that window of interest has closed. And so what this rapid attribution was attempting to do was to basically do attribution studies faster within a few weeks, and pull out just some really key results. So the idea was the results did still have to be robust. They still definitely had to be scientifically robust, stand up to criticism, but we just needed some more basic results that we could give to the general public. And there's a lot of research showing that kind of rapid communication is useful, because unfortunately we as human beings are really bad at thinking long term. I will say that absolutely you don't want to just be pushing out more and more and more communication onto a public that's already saturated with information and devaluing the importance of the information that takes a long time to produce. So I think the balance is that you need to be keeping something going so that people always are aware of climate change, not so much that the really big things get lost in the noise though. But I do think, I do unfortunately think that speed is important, because once people have stopped experiencing, say the Australia bushfires, I think the coverage of that was quite good in a lot of ways. There was a lot of very immediate research that came out to it. And I think at the time, a lot of people were making the connection that, oh, these fires were made worse because of climate change. If those reports had come out now and we weren't seeing those images every day on the news, those really dramatic videos of fires, I don't think it would have made the same emotional impact on people. So it's about differentiating between people's emotional brain and their logical brain, I think.
You don't think lockdown has increased our attention span to take a longer view in any way? I don't know. I would guess, I don't know, people have been doing more reflecting. Maybe.
I mean, I think my attention span has plummeted during lockdown, but maybe I'm a bad example. Definitely, I think climate change coverage has died off a fair bit due to coronavirus, unfortunately. But yeah, I'm not sure how that will have affected attention span. Don't know. I'm sure there'll be research coming out soon on it.
Yes, something a nice point to end on, I think, something to think about in the future. Thank you everyone for the great questions, drawing out some really good extra thoughts. And thank you from me to Ayesha. I'm just going to hand back now to Deneen wrap up.
Yep, thank you. No, just a quick thank you again, Ayesha. So a really interesting talk. Lots of top tips I think we can all take away and reflect on how we all communicate our own science, definitely. So yeah, thank you, Ayesha. Thank you everyone for coming to the first seminar. Right, thank you.
Yeah, thanks everyone for joining. Our next one will be in 2 weeks and we'll send out something shortly.